Okay, let's continue with this. We stopped here. Now let's recap the domain. Alright, is what the values the input can take, and it's defined usually together with the expression. A range is defined as the set of all images. In this case, if you have 1 mapped to 1, minus 1 mapped to 1, 2 mapped to 4, minus 2 mapped to 4, the set of all images under F is called the range, and in this case, there are just only two numbers, 1 and 4. There's a question here, what do you think is the value of F3? The tempting thing to do is F3, because you really take a look at this one, the rule is x mapped to x squared, F3 must be 9. Right? Unfortunately, the answer is not 9. It cannot be 9 because in the domain of the function here, you take a look, can only be 1, minus 1, 2, and minus 2. So 3 is not even in the domain. So actually it is not defined at all. There is no F3. Okay? Alright, let's move on. Let's take a look at example 1. Now, part A tells us to find F3. Not difficult, we just substitute x with 3 inside, you get 39. So far so good. I think this one all of us can do. What about FA? Simple, you just change your x to A, you will get 4a squared plus 3. Now C asks us to find F3A. What is F3A? F3A is essentially 4-3a squared. You get 36 plus 3. Now, what about FA plus 3? That means you're going to replace your x here with a plus 3. It's good practice that we enclose it in brackets like that. And after expansion, we will get 4a squared plus 24a plus 30. The objective of example 1 is really to let us know that by calculating, you realize that F3A, which is this, is not the same as 3 times of FA. It's not, because you multiply by 3, you will get a 12. You see 3FA is 12a squared plus 9. Clearly, and this are not the same. So you cannot just happily factorize this out. Am I right? You cannot. You cannot. What about FA plus 3? You cannot also just take out the 3 like that. It does not work. Because FA plus 3 is this. Yeah. FA plus 3 is just 4a squared plus 6. Clearly very different. So that is what example 1 is trying to say. Now what about example 2? Let's take a look at example 2. You have a G. Alright, a G here. G is defined like this. Here. Alright. Now, what is G 2x plus 1, and what is G bracket 2x plus close bracket plus 1? Now, the objective is to realize, for you to realize that these two are clearly not the same. We can easily work it out. G2x plus 1, I think this is not difficult, it's just a bit of expansion we're done. I just need us to really work it out. G2x close bracket plus 1. What you need to do is to replace the x with 2x. You realize that this is 4x squared minus 6x. Right? Then you realize that these two are not the same. Now what about C C and D, are they the same? That means you take gx whole thing square, or you take g of x squared. After a bit of calculation, you will get this. You get x squared minus 3x whole thing square. You get x4 minus 6x cubed plus 9. Alright, you expand this. However, if you just do gx square, whole thing square, this one, it is just replacing my x with x squared. You get x4 minus 3x squared. Clearly, they are not the same. Alright, clearly, they are not the same. Okay, yep. So, that's all we're trying to say. These two are not the same. Yep. Let's move on to the next idea, graph of a function. Now, given a function, we can draw its graph. But just take note, we must always take note of the function's domain. What do we mean here? Now, if I give you example 2, the function g, alright, here, which is here, x squared minus 3x. I don't think it's difficult to tell me that the graph clearly is a minimum happy face. Okay lah, not very nice, but you know what I mean. Alright? No. No need to redraw, do I? Just for a bit of pride. Let's do this a bit better. Alright. And I think this is 3, 0. Not difficult, it's 0, 0. Don't copy everything yet, but I want to say a few things. This is the minimum. Tempting thing to do, but not correct. Why? Because you must take note of the domain. In this case, in this function g, this is not the graph of g because g is a function such that x is met on the x squared minus 2 to 3x, where x must take on positive real numbers. So, you cannot draw this, you must draw this. You must. Because x can only take on positive real numbers. And why do I have the open circle here? It is to exclude the point 0, 0. X can be 0.000001, but it just cannot take on 0. All good? Yeah. So we use a hollow circle. Alright? But if I say that x must be greater than or equals to 0, there is another function, the same function g, x. How do we sketch this graph? Do we need to have a solid circle? Actually, no need. You just leave it like that. Without the hollow circle, good enough. This is good enough. If it is this one. But now it must be positive. But now this one actually means this one. So you must have a hollow circle. But if you don't, if it's just greater than or equals to 0, you just leave it like that. Good enough. Okay? Now, if g is a function, any vertical line drawn within the domain of g will cut the graph exactly once. What do we mean? Why is it so? It must cut exactly once. Let's go back to the definition of a function. A function is on second page, if I'm not wrong. A function is a relation where every element gives exactly one image. You remember the function? Remember the function machine where you put one input, only one output. One input and one output. Now, the graph should also represent it because you put one input, let's say for example, you put x equals to 3 inside. You should get one output which is 0. If you start, say, x equals to zero inside, no, cannot put put 0. X equals to 1 inside. Then you should get only one output, which is -2. Then which means that is the implication is every vertical line you draw, should only intersect 1, because you put in one x, you should only got one y. That is the reason why you must pass the vertical line test. Otherwise, it cannot be called a function. So I think this is quite clear why this is not a function, graph of a function, because you put 1. It fails the vertical line test. Once you fail the vertical line test, it means that for every one input, there's one specific input, you get 2 outputs. Apologies for the bell. It's okay. All okay? Then that's